Hello, in this unit we will be discussing sets. The topics covered in this unit will primarily include the definition of a set, its concept, as well as the various methods used to determine the elements of a set. There are no initial or necessary contents. The definition of a set originates from the mathematician Cantor, who was born in the mid-19th century. Here, we can see a photograph of this eminent mathematician. Cantor's theories, particularly set theory, faced considerable initial rejection, even from some of his teachers. However, today, Cantor's set theory serves as the foundation for all of mathematics. What is the definition of a set? Well, for us, the definition of a set is quite simple. A set is a collection of objects, and these objects can be different from one another. This means that within a set we can find various types of objects, numbers, words, and any other type of object. We will explore some examples in this unit and the following ones to clarify this concept. The objects that exist within a set are given the specific name of element. They could have been called differently, but whenever we talk about the objects within a set, we will use the term element. Normally, when naming a set, it is represented with a capital letter, such as set A or set B. The individual elements within the set are typically denoted with lowercase letters or represented according to the nature of the objects. The symbol we are introducing now is very important. It forms the basis of practically all mathematical notation. And given a set uppercase A and small a element of set A, we will represent this relationship that small a is an element of uppercase A using the symbol small e displayed on the screen. Small a, e, uppercase A. This is read that A belongs to A, or that A is in A, or that A lives in A. To be precise, it would be that small a belongs to the set uppercase A. An example of a set can be the one we have here, denoted as uppercase A. We open parenthesis, we close parenthesis, and we have A, B, and C inside. This notation is fundamental. It signifies that we have a set called uppercase A and is composed of 3 elements. The notation is very strict. We open a curly parenthesis, close another curly parenthesis, and between the curly parentheses, we list each of the elements that make up the set. Therefore, this set contains exactly 3 elements, A, B, and C. Initially, there are 3 letters, but later we will see that A, B, and C can represent numbers, a single notation or other values. Well, how many ways are there to determine a set? How many ways can we define a set? Essentially, there are 2 important methods. The first one is enumeration, which is what we've used. What we do, as we see in this example, is to give it a name, an equality, specify its elements using parentheses, and enumerate each element within the parentheses. In this set A, we see the elements 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. An important set property in which we will delve into is the fact that the elements in the set do not have an order. They do not have any pre-established order. In this case, we've listed 0, 1, 2 in a specific order because of enumeration. However, in the set, these elements exist without any inherent order. This will become clearer when we start using Venn diagrams. The second way to define sets is by description, which can employ either a mathematical or a literal expression to specify the elements that belong to the set and those that do not. Here, we have an example with a set called P. Its formal mathematical definition can be represented by the second expression we encounter. We open and close the parentheses, specifying that P contains n numbers from the set of natural numbers, where there exists an m in the natural number such that n is twice m. All the unfamiliar terminology we encounter here, which will be fully explained in the upcoming units, where we review basic mathematical concepts, essentially amounts to what we later encounter in the set, which is a straightforward description, namely the set of even numbers. We are providing a description of all the elements without enumerating them individually, essentially stating that the even numbers are present while the odd numbers are not. So far, in this unit, we've learned how to identify sets, determine whether something is a set or not, and define sets through enumeration and description. Thank you.